NVIDIA built a chip specifically designed to comply with American export rules, tested it against the performance thresholds, kept the specs inside the permitted ceiling, filed the paperwork. Then Washington looked at it, thought about it for a few months, and banned that too. This is the story of how the United States government, trying to prevent China from building advanced AI infrastructure, accidentally wrote the business case for China building advanced AI infrastructure. The H20 was not a cutting-edge chip. That was the point. After the Biden administration restricted the H100 and A100 from Chinese buyers in October 2022, NVIDIA did what any company with a $400 billion market cap and serious exposure to China would do. It engineered around the rules. The H20 had lower memory bandwidth, reduced interconnect speed, deliberately hobbled to stay under the export threshold. It still sold well. China's cloud giants, Alibaba, Tencent, ByteDance, bought it in volume because something is better than nothing, and nothing was increasingly what Washington wanted them to have. Then, in April 2025, the Commerce Department required a license for H2O exports to China. No license was forthcoming. NVIDIA disclosed an $5.5 billion inventory and receivables charge in a single quarter. Jensen Huang flew to Beijing. The timing was noted. Here's the mechanism that most coverage skips over. Every time Washington tightened the controls, it did two things simultaneously. It reduced what Chinese companies could buy from American suppliers, and it increased the political capital available to Chinese policymakers who had been arguing for years that domestic semiconductor self-sufficiency wasn't optional. Before 2022, that argument was contested inside China. It cost money. It required diverting resources from more immediately profitable industries. There were factions within the Chinese system that preferred buying from the Americans because buying from the Americans was cheaper and faster. The export controls ended that argument, not by making domestic chips better. They weren't, not yet, but by making the political cost of dependency undeniable. You cannot be sanctioned over something you make yourself. That's not a complicated insight. It just needed Washington to demonstrate it concretely, repeatedly, with escalating specificity, for it to become unassailable inside Beijing's planning apparatus. Huawei's Kirin 9000S processor, fabbed at SMIC on a process node that everyone politely describes as 7-nanometer equivalent, shipped inside the Mate 60 Pro in August 2023. It appeared on shelves with no announcement, no press release, no fanfare. Someone bought one. Someone ran a teardown. The chip existed. This was not supposed to be possible. The Commerce Department had assumed SMIC couldn't reach that node without ASML's extreme ultraviolet lithography machines, which had been denied to China since 2019. They were right that SMIC couldn't do it efficiently. The yields are low. The cost per wafer is higher than TSMC's equivalent by a margin that, in a functioning market, would make the business unviable. China's semiconductor market is not a functioning market in that sense. It is a strategic program with commercial aesthetics. We'll come back to the yield problem because it matters more than most people realize, and the way China is solving it tells you something important about where this actually ends. For now, NVIDIA designed a chip to fit inside American rules. America moved the rules, and somewhere in Shenzhen, in a building that doesn't advertise what it does, engineers who used to wait on import licenses stopped waiting. The number worth holding on to is 41. That's roughly how many Chinese semiconductor-related entities landed on the Commerce Department's entity list between 2020 and 2024. Each addition was announced as a tightening of the noose. Each addition was also, functionally, a government-issued memo to every Chinese state fund, provincial development bank, and party-affiliated investment vehicle that this particular industry required unconditional support. The big fund, Guojia Jicheng Dianlu Chanye Tuzi Jijin, which Beijing doesn't expect you to pronounce, just to know it exists, launched its third phase in May 2024. Size: approximately 344 billion yuan. That's just under $48 billion for a single funding vehicle in a single year, on top of two prior phases that had already deployed hundreds of billions since 2014. This is not a subsidy program. It is the industrial replacement project with a timeline measured in 5-year plans. What does $48 billion buy in semiconductors? At TSMC's reported capital expenditure ratios, it builds roughly 2 leading-edge fabrication facilities with equipment, fit-out, and initial operating costs included. China is not spending this money on leading-edge fabs, not yet, not primarily. It's spending it on something that gets less coverage and matters more in the near term: mature nodes. Mature nodes are chips manufactured on older process geometries: 28 nanometers, 40 nanometers, 65 nanometers, not the 3 nanometers and 2 nanometers that TSMC and Samsung compete over. The chips that run your car's braking system, your factory's industrial controller, the power management unit in your phone, the guidance systems in precision munitions. Unglamorous, completely load-bearing. China already controls a substantial and growing share of global mature node capacity. SMIC, Huawei Semiconductor, and a cluster of smaller fabs have been adding 28 nanometer capacity at a rate that, if sustained, will give China something close to self-sufficiency in that segment within this decade. The West largely didn't restrict mature node equipment exports. The assumption was that older technology wasn't strategically sensitive. That assumption is being quietly revisited. The Huawei story is instructive here, not because of the Mate 60 Pro specifically, but because of what Huawei did with the years it spent under sanctions. Between 2020 and 2023, while it couldn't get leading-edge chips and its handset business was collapsing, Huawei restructured. It built out HiSilicon, its chip design arm. It deepened its relationship with SMIC. It developed its own compiler stack, its own AI chip architecture, the Ascend series, and positioned itself to supply Chinese cloud infrastructure with domestically designed accelerators that don't require an export license because they were never American to begin with. The Ascend 910B, Huawei's flagship AI training chip, benchmarks at roughly 60 to 80% of the H100's performance depending on workload. That gap is real. It also used to be larger. The trajectory matters more than the snapshot. One company that understood this early was Baidu. Its Kunlun AI chip program started in 2011, over a decade before the export controls, partly because Baidu's engineers had watched what happened to Chinese tech companies that built on foreign hardware foundations and quietly decided they didn't want to be in that position. The sanctions didn't create that instinct. They validated it loudly in front of every Chinese boardroom that had been skeptical. There's a factory in Wuhan, a YMTC facility, NAND flash memory, opened in phases starting around 2019, that became something of a symbol for this dynamic. YMTC was put on the entity list in December 2022, shortly after Apple was reportedly evaluating its chips for use in iPhones. The listing froze that conversation. It also ensured that YMTC's engineers, who had been competitive enough for Apple to consider them, would spend the next several years with no alternative customer base except domestic E, and therefore no alternative but to get better. Sanctions as accelerant. It keeps happening. Washington keeps being surprised. Let's be honest about what China cannot do yet, because the bullish narrative on Chinese semiconductors has its own blind spots, and ignoring them makes the analysis worse, not more patriotic. The yield problem is real. When SMIC produces chips on its 7 nanometer equivalent node using deep ultraviolet lithography stacked in multi-patterning configurations, it does so at yields that industry analysts estimate somewhere between 50 and 70% of what TSMC achieves on comparable processes. That means for every 10 wafers that go in, 3 or 4 produce chips that fail quality checks. At TSMC's volumes and margins, that's recoverable. At SMIC's current scale, with state subsidies absorbing the difference, it's manageable. But it is a ceiling on how fast China can ramp production of leading-edge adjacent chips without solving a materials and process control problem that took TSMC 20 years of iterative learning to work through. The equipment gap compounds this. ASML's EUV machines remain out of reach. The Dutch government, under sustained American pressure, has maintained export restrictions since 2019. Without EUV, achieving true 5 nanometers and below requires multi-patterning techniques so complex that the margin for error at each lithography step compounds across the entire process. It's not impossible. It is expensive, slow, and difficult to scale in the way that a commercial semiconductor industry requires. And then there's the software layer, which doesn't get enough attention. Chip design runs on electronic design automation tools, EDA software, dominated by 3 American companies, Synopsys, Cadence, and Mentor, now owned by Siemens. Export restrictions on EDA tools were tightened in 2022. China has domestic alternatives, Empyrean technology being the most cited, but the gap between Empyrean's capabilities and a full Cadence or Synopsys toolchain is not small, and it's not closing quickly. Designing a competitive AI accelerator without access to best-in-class EDA tools is like writing a novel on a typewriter while your competitor has a word processor with autocomplete. You can do it. It takes longer, and the output shows the constraint. So the counter-argument has weight. China is years behind on leading-edge fabrication, constrained on equipment, limited on design tools, and burning state capital at a rate that produces chips which cost more and perform less than what Taiwan makes commercially. A purely market-rational assessment says this program should struggle. Here is where the reframe lives. China doesn't need to match TSMC. It needs to be good enough, at sufficient scale, for sufficient use cases that American export controls stop functioning as leverage. Those are different thresholds. The first is a generational semiconductor engineering challenge. The second is an achievable industrial policy target within a decade. Huawei's Ascend chips don't need to beat the H100 to run inference workloads on Chinese large language models. They need to be good enough that Baidu and Alibaba can build products on them without the products being embarrassing. That bar has arguably already been crossed for some applications. DeepSeek's R1 model, which caused its own small crisis in American tech valuations in January 2025, was trained on a cluster of Huawei Ascend chips alongside NVIDIA hardware. The exact ratio is disputed, but the fact that Ascend was in the training stack at all was the signal. My opinion, the American export control strategy was not wrong in its instinct, but catastrophic in its execution. Restricting EUV machines in 2019 made sense. Allowing SMIC to buy deep ultraviolet equipment in large quantities through 2021 while planning the broader controls gave China a 2-year runway to stockpile the tools it needed for exactly the workaround it subsequently deployed. The sequencing was backwards. You close the last door first, not the most visible one. The doubt I can't fully resolve. We don't actually know what's happening inside China's leading semiconductor facilities at the process level. The yield figures are estimates from supply chain analysts and equipment import data, not audited production statistics. It's possible, I'd put it at non-trivial probability, that Chinese fab capabilities are either better or worse than the consensus estimates. And we won't know which until a product ships that reveals the answer, the way the Mate 60 Pro did in 2023. What we do know is that the gap, wherever it currently sits, is moving in one direction. Pull back to the shape of what's actually happened here, across 3 years of escalating controls. The United States identified semiconductor technology as the critical choke point in great power competition. Correctly. It built an export control architecture designed to freeze China at its current capability level, reasonably. It then applied that architecture in a sequence that gave China's domestic industry time to adapt, gave Beijing's planners political cover to spend without limit, and gave Huawei specifically the conditions under which it had nothing to lose by pushing its fabrication partners to their absolute technical ceiling. The policy was sound in theory and leaky in practice, which is the most dangerous combination in strategic competition. It signals intent without delivering effect. What comes next is not a mystery. It's a logistics problem. China's semiconductor program is now too large, too politically embedded, and too far along to be reversed by any realistic tightening of export controls. The window where controls could have prevented a domestic industry from emerging closed sometime around 2021. What controls can still do is slow the rate of improvement, raise the cost of each generation, and preserve a performance gap that matters for the most demanding applications. Frontier AI training, extreme ultraviolet lithography, sub-3 nanometer logic chips. That gap is worth maintaining. It's just not the same as the gap that existed in 2019, and pretending it is produces bad policy. The NVIDIA story ends, for now, in a place nobody wanted. NVIDIA loses meaningful China revenue. The company generated roughly $17 billion from China in fiscal year 2024, before the H20 restrictions hit. Chinese cloud companies pay more for worse chips and build procurement strategies designed to never be in that position again. American semiconductor equipment companies watch their China business evaporate while their Asian competitors, Tokyo Electron, certain Dutch and Japanese suppliers operating in gray zones of the control regime, absorb portions of what's left. And somewhere in the gap between what China can build today and what it needs to build tomorrow, an entire generation of Chinese semiconductor engineers is getting the kind of problem-solving experience that doesn't come from reading about it. That last part is the one that should concentrate minds. Capital can be replaced. Equipment can be reverse-engineered or routed around. The human capital problem, the accumulated tacit knowledge inside a functioning advanced semiconductor ecosystem, that's the actual moat. And the export controls, by forcing Chinese engineers to solve problems without access to the best tools, are generating exactly the kind of hard-won process knowledge that built TSMC's own advantages over decades of constrained, pressured, iterative development. My prediction: within 5 years, China will have demonstrated a domestically fabbed chip at true 5 nanometers or better, at yields that are commercially viable with state support. It will not be competitive with TSMC on cost. It will not need to be. It will be good enough to run the AI infrastructure that Chinese companies require, and it will be entirely outside American licensing jurisdiction. At that point, the conversation in Washington will shift from how do we prevent China from getting this capability to how do we ensure our own ecosystem stays far enough ahead to matter, which is where the conversation should have started. The export controls bought time. The question nobody has cleanly answered is, time for what exactly? Time for American chip companies to build alternative markets? Time for allied fabs to scale? Time for a diplomatic arrangement that never materialized? Time, it turns out, is only valuable if you know what you're spending it on. Washington released a chip. NVIDIA redesigned the chip. Washington banned the redesigned chip. China decided to build its own chip. The policy achieved every intermediate objective and is losing on the terminal one. If you've been watching this space and found this useful, share it with someone who still thinks export controls are a strategy rather than a delay. That's not nothing, but it's also not a plan.